Good morning to everyone. I'm Teresa Piovano, a PhD student from the University of Bologna. And I'm here today to talk to you about data collection. And so how data collection can be applied in an agronomic experiment and can be useful within the Frontagnex project. In the following presentation, I will start defining what is an experiment. So starting from the beginning, then we will talk about the variables, different kind of variables. So the controlled variables, the dependent variables, and the independent variables. We will identify which type of dependent variables can be useful within agronomic experiments, how to measure the dependent variables, how to analyze them, so through the destructive and non-destructive analysis, how to organize your data, and then I will provide some practical examples, simple example, to see how data collection can be useful within the Frontagnex project. Starting from the beginning, I will try to be quick on this more theoretical part. I would like to define what is an experiment. So an experiment is a data collection method where you, as a researcher, can change some variables and observe their effect on other variables. What is a variable? A variable is a factor, a character, or a condition that may differ in an experiment. And the variable that you manipulate are referred to as independent, while the variables that change as a result of manipulation are dependent variables. The standard experimental conditions are named controlled variables. So what are the controlled variables? As said, is everything that you wanted stay constant and unchanged during all over the experiment. It can change obviously depending on the type of experiment that you are conducting. And some example could be, for example, the type of plant used, the pot size, the soil type, the solution, and going on. So why controlled variables are so important? They are really important because they can reduce the impact of confounding results, improving the internal validity of a study. And by doing this, it's possible to prevent the research bias and to demonstrate correlation or causal relationship between your variables of interest. I cited the confounding result. When I talk about confounding data, I'm referring to mixing of effects, wherein the effects of exposure under different conditions can give an outcome that is mixed in with the different effects of additional factors, resulting in a distortion of the true relationship. So even if the controlled variable are not the goal, are not what we are looking for in our experimentation, it's really important to have it, to define them, because they can impact the results. In the previous slide, I already gave some example. In the slide, I provide like an example of a possible evaluation of the organic fertilizer for lettuce cultivation. And in this case, our controlled variables will be the type of soil, the amount of water used, the temperature, and the pot size, for example. Then we have the dependent variables. What are the dependent variables? We can divide them into categories, into principal categories, like the vegetative and quantitative or morphological dependent variables. That could be, for example, the yield, the plant type, the leaf area, or the qualitative dependent variables, like, for example, the soluble soil content, maturation degree, treatable, the acidity. Through the first analysis, the first measurement of the dependent variable, we can have primary variables, so directly obtained from the sample measurements. And thanks to the primary variables, we are able to calculate the derived variables. So those variables that are computed from one or more primary variables, like, for example, the percentage of variation, the growth index, and going on. So how we can measure our dependent variables through, obviously, through instruments, through tools. We can have analogical and digital instrument, analogical like the meter, for example, and digital like the scale. It's also important to introduce the concept of error risk, because what we are doing in our experimentation is trying to reduce as much as possible the error risk. Obviously, using analogical instrument can reduce the risk of observational errors. It's also really important to define the method through which we are going to carry out our data collection, and it could be better if it's always the same person that performed the analysis, always to reduce this error risk. Something that have to be decided in our design experimentation is the number of sample. The minimum statistical relevance of sample that have to be taken is 3. Obviously, increasing the number of replicates can allow us to have more solid analysis. Defining the number of sample and replicates that we are going to take, we can measure our dependent variables through destructive and non-destructive analysis. The non-destructive analysis are, as the word says, measurement that doesn't impact the physiological part of the plants, like so measure the plant height, the number of flowers, then counting the number of leaves. This kind of measurement can be done also once a week, but obviously the frequency of the measurements can change depending on the type of experiment. Then we have the destructive analysis that are usually done at the beginning and at the end of our experiment, and that consists in like the measurements of the leaf area, the yield, the fresh weight and the dry weight of the different parts of the plant, like flowers, leaves, stem, and going on. As I said, those kind of measurements are usually done at the beginning and at the end of our experimentation. If we are looking for I don't know, to study the physiological growing of our plants, it can be done obviously also during a particular specific phenological phase to try to understand and to analyze the behavior of the treatment that we are using maybe on our experiment. Also, the organization of our data set is really important in order to analyze our data after the end of our experiment. Usually, we place the independent variable on the first column. That it's the treatment that we are using. In this example, it's like different substrate used, like peat, coconut, and going on. Then we have the sample number, the replicate, and the dependent variable that we are measuring: plant height, leaf area, weight, fresh weight, dry weight, and whatever. But then talking about more concrete, more practical aspect of the data collection, I provide you like 3 examples to how data collection can be useful in within the Frontac Next project. So it can be useful to improve the food security, to enhance the sustainability of the growing system, and to evaluate the economic viability. Let's start from the first concept. How can we evaluate the food security? EFSA published that the goal for an healthy diet would be to eat at least 80 grams of leafy vegetables per day. Knowing that this value is our goal to conduct an healthy life, how can I know how many square meters I have to I need to achieve the goal? So how much leafy vegetables I need to produce? I can calculate it, measuring the planting density, the growing cycle length that can vary obviously depending on the species, and the yield. By knowing the yield per plant and the density per square meter and the cycle length, I can know how much I produce per square meter and per day, and then how many square meters I need to reach to the goal. Another example is to enhance the sustainability of the growing system. So in the following slide, I propose an example that can be done, but obviously it can vary depending on what we are looking for. So here we have an example of an experiment that evaluates the effect of the different substrate on tomato cultivated in an hydroponic system. So in this case, just to clarify what I said before, we will have the independent variable that are the different substrate that I'm using. And one of these three substrate, in this case, coconut fiber, rice hulls, and peat will be the control. So if in my system I'm currently using rice hulls and I want to compare my production and the sustainability of my production with different substrate, I will have the control that will be the rice hulls, and then two different substrate that I'm going to test. Then I will have the controlled variables that what will stay unchanged, as I said before. So the temperature, the nutrient solution, the amount and the quality of my nutrient solution, the shadiness, the pos. And I will able to measure and to analyze my data and my plans through instruments, scale, tape, meter, oven, and going on. In this case, I provide you an example of an experiment that analyze one single independent variables, that is the substrate. It's also possible to combine different independent variable that I'm gonna analyze during my experiment. Like for example, I don't know, substrate and different solution in my hydroponic system. So this is just an example. Here are the measurement, non-destructive, and then in the following slide we will see the destructive measurement that can be taken in this case once a week, as I said before, like for example the leaf length, the leaf width, number of flowers. Here we have an example of destructive analysis measurement that can be done at the end, at the beginning of our experiment, or in a specific phenological phase. And we have the screenshot of Easy Leaf area, that it's a really simple tool, an application for the smartphone that can be used to measure the leaf area. Another parameter linked to the sustainability that can be measured, for example, during our experiment, is the water use efficiency. So how much my system is sustainable, how much water I'm using. This can be easily calculated through the ratio between the biomass produced, so the yield produced, and the water used. So, for example, if my system have a water tank of, I don't know, 200 liters, for example, I know that at the beginning of my experiment, I'm going to fill my tank of 200 liters, and once a week, I will add a specific and determinate amount of water. So at the end of my experiment, I will be able to define the water that I used during all over the cycle length, and evaluating the yield, the biomass produced, I will be able to calculate the water use efficiency of my system. So is my system sustainable in terms of water use? This is an example of a study that Francesco Orsini and Giuseppina Pennesi, so my group, conducted in Myanmar in Brazil, where they compared the different systems in terms of water use efficiency. As you can see in these graphs, the efficiency of the water use for the soilless system is definitely higher. We have 44 grams of fresh weight per liter of water used in Brazil, and 37 grams in Myanmar. So this is an example of something that can be studied and applied. Then I would like to propose you an evaluation of the economic viability, because obviously data collection can be useful for talking about the measurement of the physiological part and the agronomic part, but also the economic part in a companies, it's definitely important. So before starting, I would like to tell you that this is a simulation. So all the data that I propose you and that I used for this simulation are taken from some companies and from the website that are strictly linked to the Italian market. So I'm proposing an example that it's vinculated to my country, but it's just to understand the method and to provide some examples. So I created a simulation of polycarbonate greenhouse of 225 square meters that was equipped with an electrical system, a fertigation system, a ventilation system, and 8 hydroponic cultivation benches, each measuring 1.6 meters for 3 meters. So at the end of the dance, the total cost for the material, including also the assembly, was around 57,000 euro. So the cost for square meter, knowing the total surface calculated, was 256 euro. So knowing the total cost of my first investment, how can I know how much I have to produce in order to amortize the total cost of the material? I can calculate it knowing the cost per square meter and dividing it for the number of months. So in this case, I estimated a lasting of 10 months. It can vary, obviously, depending on the type of structure. I take a structure of a greenhouse, as I said, in polycarbonate with the main structure in zinc. Through the amortization price and through this calculation, I'm able to define the capex for months and for years. So what is the capex? Is the capital expenditures that are the investment expenses that therefore are more aimed at long-term growth of the company. Investments, obviously, the first investment heavily have a heavy balance on the sheet of working of the capital requirements, because they are generally constitute the significant financial commitment. And so obviously it's important to define how can I return to my first investment. So knowing so this is another example that can be applied, that I applied to Italy, but it can be applied to every country. I know that from the website, the average market price in Italy for the 1 kilogram of lettuce is around 70 cents. So knowing that, and knowing that the average lettuce yield per cycle is 12 kilograms square meter, and that the cycle length of the lettuce is 31 days, I will be able to define the revenue per square meter that is obtained multiplying the revenue per kilogram for the total yield for the style length. So I know that for square meter, I can gain 9 euro, so 2,000 euro for all the greenhouse. That is just one. Usually company has more than one, so this is a simple example. So knowing my revenue for month and for square meter, I can define how many number of cycles I have to do to repay my first investment. And I can calculate it dividing the total cost per square meter for the revenue per square meter. So I know that in 28 cycles of production of lettuce, in this case, this is an example, I can return my first investment. Here I made a simple graph just to see how my money are distributed on the revenue and on the costs. This graph represents the OPEX, the CAPEX, and the net operating margin. So we already defined that the CAPEX, the capital expenditure. Then we have the OPEX. OPEX is the short for operational expenditure, and it refers to the ongoing costs required for the day-to-day running of my business or system. So it includes like the utilities, like cost for the electricity, for the heating, the labor, so the wages for the employees who manage and maintain the greenhouse, the supplies, like the cost for the seed and the fertilizers. And then we have the net operating margin. This is it measures the net profitability of a company after the accounting for both operating expenses, OPEX, and the capital expenditures. So it measures the operational efficiency. This formula indicates how much of the total revenue remains after covering all the operational and capital expenses. What it doesn't take into account are the taxes that change it a lot by country. So as we can see from the graph in this simulation, our net operating margin, so what we have, our profit, just not taking into account taxes, is the 66%. So I know that in this case, my production will be definitely positive. So my production will cover my costs. Here is just an example to define the price of selling. Obviously, the price is not defined by the producer, but it's defined by the market. But just to have an idea of my optimal price of selling, I recreated this simple graph. As we can see, obviously, it's a linear graph. Increasing the price of selling, I increase my revenue, but this could be helpful in the planning of my company just to define which would be my optimum of selling. So this was an example to understand and to highlight the importance of data collection within the Frontac Next project and for the good going of a company. Obviously, there are many other factors that can be taken into account, but I hope that it was useful, and I thank you for your attention. If you have questions, feel free to do it.
Thank you very much, Teresa, for your presentation and also for staying perfectly in time.
I tried to.
I have one question, if I may start. Yeah. Because
sure.
of I really liked your hypothetical economic analysis at the end, because it shows that we can even do such an analysis when some data is missing, because we can take, let's say, representative data from reports of companies or publications. But what I was asking is, wouldn't it be important also to include not just the revenues from the yield, but also incorporate potential losses? Because sometimes a company may not be able to sell all the yield, and then you lose actually revenues, and you would have to maybe include, let's say, 5%, 10% of a yield loss due to whatever reason, just maybe because you can't sell it in that particular month.
Yes, sure. Data collection can be applied, and it will be better to apply it also to different scenarios, because obviously there are things that can be controlled, and so it's something that have to be taken into account.
Yeah. Okay. So it's just an additional variable that one could consider.
Yeah, thank you.
Okay.
For your contribution. It's definitely something that have to be taken into account.
Okay.
If you have other questions.
So maybe from my side, now not all hydroponic systems in the project are yet running, but I would assume if hydroponic systems wants to do a controlled experiment, because in the project we are looking, I mean, we want to show that these systems are efficient compared to conventional production like soil-based or rain-fed systems. So then the partner who would like to actually compare that could go back to you and say, okay, let's talk about it more precisely. How should I control my experiment, right?
Yeah.
Okay.
Yes, yeah,
okay,
definitely.
Wonderful.
I propose you an example of a paper that some colleague of my conducted, my supervisor did it here. This is just an example. This is just Francesco Titi. Yes, exactly. This is obviously just an example, but I think it was useful to to show you, because I think it can be replied and applied also in this project to evaluate and to compare different type of production and to see the sustainability of the in terms of production of water use, for example, but also on the economic side, because
yeah.
sustainable.
Thank you very much.
I would like to say that, of course, there is a lot of material in literature, so we can provide to our partners, to you, like if someone is really interested to do this cooperation, so maybe to study better, like the own case. So like we can help them with our expertise, or like sending materials that can be useful as well.
I know that El Boston is already comparing strawberries on soil and hydroponics, and of course for them too, depending on whether they have to pay a price for water, it's also important to know more about water use efficiency, I would imagine.
Yeah, we got already in contact with Gaia concerning the humidity, and she sent us also a paper in this concern. So
okay,
we're
great.
thankful.
See,
yeah.
My assumption was right.
Sama, I don't know if the material was useful actually, because you didn't answer me, but if you have like more question, you can write me like whenever.
Yeah, thank you.
Anybody else who would like to ask a question? No? And I assume that the presentation was recorded? And the
Yes.
slides, maybe as PDF, are going to be available on
Sure.
MS Teams.
Yes.
Okay.
Sure.
Perfect.
And in the Knowledge Hub as well.
And wonderful,
Yeah,
okay.
Smini.
Yeah.
Okay, great.
Okay, perfect. Thank you so
Thank
much.
you. Yeah, thank you very much. I think this was the last webinar in that series right now, right?
Yeah.
Yeah, but wonderful. Thank you very much.
Thank you for your attention.
Then if nobody else has questions, I think, I don't know if Elisa is here. I just took over the moderation.
No,
she's still in a
not here.
meeting. Yeah. Then I would say we leave this meeting and go back to our Frontac Nexus weekly meeting, which is today also a project steering committee meeting.